Welcome back. In this section, we are going to start the hands-on steps, and to follow along, we have a new lab which you can also access if you have bought the UFFCN Cloud Platform course, or you are already premium member, or you have access to new ABAP on HANA bundle. So if you have the course, then you will be able to access. Initially, this document is live for everyone, but over time we are going to restrict access to only enrolled users. Now, most of the time I get a feedback that the code is something which you are not able to access, or the documents are not updated regularly, and you have a copy of document which is either developer guide or developer steps guide, then they are not updated. So in this case, we will try to update and try to keep up with CAPM as much as we can. And also, while creation of this course, I'm going to follow along this UFFCN lab, which will help you also to follow along when you do hands-on. So let's get started. Our first objective is to install the NPM registry. Now, the first step is to add that. We have already added npm.sap.com when we worked with microservice. If you remember, we were able to access the app router, and those libraries are part of npm.sap.com. So we have already added this. If you have not yet added, or you are confused if this registry is part of my npm repo, then what you can do is you can just go to your terminal or command prompt, and let me first show you how you can check. You can just run this command npm config list. So let me copy this and come back here, and I can basically see here the registry npm.sap.com. So this is one of the registry. The global registry for npm is this registry.npmjs.org. So if you try to download any node module, by default, this is the registry which it will try to reach and try to download the libraries. Now, when we create a node application, I'm going to give you little background for users who are new to Node. Then a node application depends on multiple modules. And this module can be express module, can be passport module, what we have already seen in the last section. Now, these individual modules, or you can also say library, or you can also say packages, are something we need to download. And if you're trying to test them locally, then they need to be present locally. And you can actually use those modules and run your application. Now, these modules, when we create a node application, are also sometimes referred as dependencies, because if I'm making a express application and somewhere I have coded that to use passport module inside it, then I can say that express module is dependent on my passport module. So you will see these terms very often, and they all mean something related to how the operation is carried out. So if you are a new, then dependency, modules, library, package, they are all pointing to something similar or something same, which is the code which you have added or the module which you have added. So that is one point we have to be again and again get reminded of. So this module or dependency or this package, they all mean same in a nutshell. So that is something which is kind of a very basic, but we need to always remember the basics. Okay, the next step which we will do. So for user who have not adding this registry is just a single line of command. You can just come here and copy it, and it will run in few seconds, and this npm.sap.com will be added as a npm repository. Then we are going to install globally SAP CDS DK. So what it allows us to do is, when we are going to make a project, we are going to use CDS and init. So it is similar to what we have seen npm init, and it basically creates a node project for us. So this SAP CDS DK will allow us to get access for the CDS command, which we can use in the terminal. So if I copy this code, or I can just write npm -g, this is a flag. So when I write -g, that means I can go to any directory and I can run CDS and the command will still work. So SAP -g @ SAP/CDSDK. So That is the command. You can also copy it and you can also type it. So yeah, I have missed install. So before -t, it should be either install, or you can also write just I, which is the short form of install. And it's going to take few seconds. And within that second, what it is trying to do, it's trying to reach our @SAP/CDS/DK and trying to get the package and globally installing it. So I can go to any folder and I can use this CDS command, or I can use whatever functionality this package will have. So the functionality is the CDS command. And with the help of this CDS command, I can create an empty project. I can build a project. I can run a project. So the CDS command is going to be synonym to npm. So if you have already seen our previous module, we used npm init to create a project. We use npm start to run a script. So in CAPM case, we are going to use CDS command for that. Okay, so now what I can do is I can basically write CDS help, and it is going to tell me what are the possibility with the CDS command. So as I told you, init, compile, import, serve, environment, build, deploy, version, and help. So these are the usage of CDS command. Once we install the CDS DK globally, we have access to CDS command. I can go to any directory. So I can go to the one level up and also use the CDS command. So if you don't install it globally, you will only be able to access CDS command to the directory or in the directory where you have installed it. Okay, so this steps also shows the same thing. You can basically see the CDS command and you can use CDS help to get what are the things which it can do. Okay, coming back to our terminal. Now you might be wondering, okay, what are the other packages which the npm.sap.com or this particular registry holds? So there is also a very nice way to look into it. So you can just write npm search and let me copy the command just to avoid typos if any. So npm search -- registry and the link for that particular registry. And at the end, I have added SAP. So it will show you the list of packages which is present inside. So @app router, we have already used that. We have already seen @/xssec for the authorization. So we have already used this library, and now we are going to use @/CDS. There are multiple other libraries, and by the time you are actually working with CDS, there might be a lot more libraries added, or some of the library might be depreciated. So these things keep on changing or keep on evolving would be the right word for that. Okay, so now what we have done, we have just started the installation process. If you go in the right hand side, we started with the adding of the npm registry, then we confirmed the installation, then we added the CDS command globally with @SAP/CDS/DK. After that, we checked if CDS is installed, and at the end we were able to see what are the other packages which are part of this npm.sap.com repository. Okay, so the next thing is to start with our app development. I'm going to create a very simple hello world service, and we will try to understand how the ES6 syntax are written within this creation process, and also how the CDS actually works when we try to create a service. So internally also we are going to go a little bit, but this is the level 1. This is the level 1 of the CAPM. So we are going to focus on basics, which are level 1 basic. You will see that in the consecutive level, like level 2, we will go inside the library and explore more. But in this level 1, I want to give you a overall look and feel and end-to-end application experience with CAPM, which is necessary to get a feel and then go inside. So you will be not overwhelmed when you go inside the library and you can link different points together. So let's catch up in the next section where we work with the Hello World service example. Welcome back. In this section, we are going to create a simple Hello World service using CAPM. Now, our focus here is to show how easy it is to create a simple Node.js service using CAP, and let's get started. The first thing which we will use is CDS init to create a project. So let me go to my terminal, and here I'm going to make a folder, and this folder is going to be my folder of demo1 where I want this project to exist. So change directory demo1, and here I'm going to use CDS init. Now this is similar to what we did in the last section. We used npm init to create a project. Now the output of npm init was a package.json file, and this package.json file basically contains a structure which we edited in VS Code. We added dependency, and we can also do npm install to download those dependency, or we can just add npm install and the dependency will be added to the package.json file. But in this case, the CDS init, the dependencies or a lot of dependencies will be downloaded, and we will have a folder called node modules, and inside that all the modules or the dependencies will be created. So let me run this. It's going to take few seconds because it's going to download a lot of modules and place it inside node modules folder. And I can go also to this particular folder here, and let me add this to my VS Code. Automatically VS Code will open the project for us, and here what I can see, the content of the file is .vs code. This is for my VS Code to maintain information about the project. Then I have the node modules, then I have .cds_src.json, then I have packet.log.json and packet.json. Now the essential file required for this example is package.json only. .cds_src.json file, what is the functionality of, we will see later. Packet log.json is generated whenever we have a node module added to the project, and for now we have only the need of packet.json and the dependency which are inside node modules. So inside the dependency, what you can see is we have @SAP/CDS. There is a version to it, and then there is Express. So these two dependencies are the modules which are getting used in our project. So where is this @/CDS? So if I go inside my node modules, I go to @SAP, then I find a folder called CDS. Now I can have multiple other modules like @SAP/AppRouter/accesssec. So all that modules, if I install, then I will see multiple folder inside @SAP. So if I go inside this CDS folder, you can see a well structured app. So if I go in server.js, then you will find some similar syntax. So you can see here app equal to express. You can also see app.use and app.listen. So these are some of the code which is similar to what we did with the microservice app. In the microservice app, we created an app, we used Express to create the app, and then we use Passport, and we also use multiple other modules like JWT strategy, and then we made the app at the end listen to a particular port. So all this functionality is inside your @SAP library, and when we run the code of CAPM, then you will see that this is the launcher, or this is the part of the code which starts the server. So we will come to that point where we actually will be starting the server and testing it. But for this use case, I'm going to create a very simple service. So I'm going to make a folder. Let me make a folder quickly. I can make a folder, and let me make this folder name SRV, and it stands for service. So this folder is going to contain my simple srv.js, and let me have one more file with the same name, which is having the CDS representation of the service. So first of all, I'm going to write the JavaScript implementation. So I can create a module const my service demo equal to a function. So this module is basically a function which take service object, and on read part of that particular service if I try to read it. And on read part, I can basically create a function which is going to take request and response, and this function is going to return, let's return some hard-coded value, hello world. Okay, and at the end I'm going to use module.export to export this module, and I can export multiple module, but for now just my SRV demo, this particular function I'm going to export from this JavaScript code. Now one thing which we can do here is we can basically rename it to some simple string also, like my function name. So let me keep it all small, my function name, and this is the name of the function. This is clear now. Read sometime can be treated as a keyword, so we'll not use read as a function name for now. Let me keep it very basic and simple. Now what I will do here, I will basically come to this .cds part. Now in the CDS part of the service, we basically define how the service is, what particular module this service is based on, what will be the return type, will it be readable. So all that definition, like we define a variable, we define the service in the CDS file, and the internal implementation or the functionality we write in this JavaScript file. Okay, now we have a .cds extension file in our VS Code. Then you can also install a plugin. If you go into tools.hana.ondemand and here go to cloud, and if I go to the cloud, then I will reach here. Then I have to scroll down, and there is this VS Code plugin here, CDS language support for Visual Studio Code. So this .vsix file you can download. So this .vxix file is basically a plugin file. I have already downloaded it, so I will not download it again. And you can basically go to your VS Code, then you can go to the plugin section here, this square box in the left hand side. Now you can click here in the extension where the 3 dots are there and install from vsix, and here you can select the vsix file. You can install. Now one problem which will come in my particular VS Code is that it is one version above the 1.2. It is 1.3 version of the VS Code, so it is saying that the extension is incompatible. The other option, if you are already having 1.3 VS Code, is to select certain non-official plugin to highlight or to work with CDS file. But if you're working with 1.2 VS Code, then it will be all okay. So if I go here in CDS, there are a couple of plugins we have. So this ABAP CDS language support plugin you can install. This is a plugin which is not from the official source. You can see that the author is not SAP. So this is not from SAP, but it will still highlight your syntax. So you can either use the 1.2 version of VS Code, which will give you language support for .cds file, or you can use some third-party plugin as well. The better will be to use compatible version of VS Code, which is 1.2. Okay, now creating the CDS file. What we can do here is we have already created this service, which is what we exported, my SRV demo. Now in the CDS file, what I'm going to do, I'm going to basically make my SRV demo as service. So if I just write service here, then it gives me a template of service, and I'm going to copy my SRV demo here. And inside the service, I'm going to define a function, and this function will be my func name, which is the function name which I have given here, and it is going to return. So that is what we have, and here the curly braces representing my func name is a function. Okay, so let me also just simplify this, my foo bar. So that is the standard convention of naming a function, so I can use that as well. Easy to pronounce, my foo bar. And I'm just writing here what is the return type of this function, what is the argument it takes. It doesn't take any argument, and it just returns a string. So that is what it is. Okay, so if I come back to my terminal, what I can do here is I can basically run this particular application by writing cds run, it will basically host my application in server with port 4004. This is the place where it is going to run the service, and I can copy this and I can go here to the web browser and see what we have. So in the home page I can see my SRV demo, and there's a metadata link. I can click on this my SRV demo, and this is a metadata. I can call my function which I have just implemented with, this is the function name, my foo bar. I can call this function with the curly brace, and what it is going to return in the value is hello world. Now I'm going to complicate this example a little bit by passing something in the request. So how can I do that? I can assume that there's something in the request, and I can add, let me just pass hello here and add here request dot data dot message. So imagine I'm passing a message, and this message is something which we are going to pass. Now the appropriate changes should be done also in the definition. It should say that a message is passed which is of type string. Okay, that's all, no other changes. And now if I come back to my browser and I can say message equal to new world, and let me run this. Now we are not getting the data as per we intended. Now why is that? Now we need to restart our server. I can stop the server with Control C and run again with cds run. And now also I'm going to change this double quotes to single quotes and run the URL. So it basically works now. I have hello new world. Now why this new is concatenated with hello? Because there is no space initially. I can just add space here and then I have hello new world. So that is how you can pass a request to your service which is treated as a function. So let's recap what we have done so far. We first started with a project. We created it with CDS init. We got package.json, package.log.json, node modules. Then we can also go inside the node modules and we saw all the individual modules we got. We also saw the content of package.json, which is already having dependencies at the rate SAP CDS and Express. After that, we saw the content of the CDS module and also the server.js file where the app start code is present. And then we created a simple JavaScript file for our service and also a CDS file for our service. And we ran the particular code with cds run command. And it started our server in localhost 4004. And then we tested our particular example by passing a request parameter in the URL. Okay, so this was what we have achieved so far. We have basically created a very simple service using CAPM and tested it in our web browser. So let's catch up in the next section where we are going to work with CDS data as well, where we are going to define the data structure with CDS. How to do that? So let's catch up in the next section. Hello and welcome back. In this section, we are going to focus on creating our DB schema and then using those database data, what we have entered, as a source or as a source for the service and trying to expose that through our API with our services. So for that, what will be the steps? We will be creating a database folder, and inside that database folder, we are going to first create a structure. So we will create a CDS structure, and then we are going to create a simple CDS structure of a student. And once we create this CDS structure, we are also going to add some data. So this data will be present in a folder called CSV, and this CSV will contain a file, and this file name we can give whatever we want. And this file will be containing the CSV data, which is the comma separated data or delimiter separated. In this case, the delimiter is comma, which separates different value. So we will create the data in CSV format. then we are going to implement the service referring to this CDS structure. So we have already defined a CDS structure. According to that CDS structure, we are going to create a service, and then we are going to install a local SQLite 3 database. So this is going to help us to test our setup or test our app locally. When we deploy our application to cloud Foundry or Neo, then we are basically going to either switch to HDI, which is HANA database instant, a small schema. We have already seen in the last section what is the difference between HANA database and HDI container, or we can also use HANA database in our Cloud Foundry. If you have a paid account, then you can also use your HANA database. But in local system, we can quickly do test with the help of SQLite 3. There are pre-built setup which in the CAPM library you will find to put CDS data in SQLite 3 and test all the setup what you have, and we will see the final service which will give us the data. So this is all the things which we will do in this particular section. So let's get started. So I'm going to start my development with VS Code. We have this folder called demo1 which contain our service, what we did in the last section, my simple srv.cds, my simple srv.js, and let me maximize it. And what I'm going to do, I'm going to create a new folder called DB, and inside the DB I'm going to keep all the structure for my database in CDS format, and also I'm going to keep my data, and my data is going to go inside a folder called CSV, which is again inside the DB folder. Okay, so that is the structure. So let me create a new file here, and I'm going to call it student.cds. So this student.cds is going to contain the structure of my data, which is the student record here. Remember, we are using the LMS system. We are basically trying to create a LMS system, learning management solution system. So for that student.cds file I have created, which tells what are the data fields of the students we need. So here I'm going to tell entity, and this is going to be student. And if you go in the example here, I have called it students. So better to rename it now, because then if you are following along and copying the code also, then it will be same in my code and also the code which we have in the lab. So let's come back here, entity student, and it's going to have email, which is of type string, then first name, then last name. So this 4 fields only we need: last name and date sign up, which is a date. Okay, so this is going to be string, and then you have to tell how many characters you need. 65. Let me just confirm. Yeah, 65. Then 20. First name is having the limit of string 20, last name also, and the date here is of type date. Okay, now not data but date. Okay, you can also have date time, but for now I'm just taking the date type or date data type. Also, I will create a namespace here so I can basically separate my structure. So it can happen that I may have to define some other structure. So based on the namespace, I will be able to point that which structure belong to which particular module. So mostly namespaces are to modularize the code and keep it categorized. So for example, what is the namespace here? mycompany.hr.lms. So I can just use mycompany.hr.lms. So students here is basically a entity which is inside mycompany.hr.lms. So the absolute path will be mycompany.hr.lms.students. So that is the path if you want to refer to this entity. So from outside the file, if you want to pinpoint that, okay, this is the entity I'm referring to, then you have to basically use this namespace. Now you can also have other CDS structures like your teachers or courses, and they are all part of your LMS project. So this namespace is primarily used to categorize different entities. So we can all know that students is the entity which is defined inside LMS. So it is part of the learning management solution. Okay, so we will see it in action also when we try to use the student entity there. Then we have to basically use the namespace to import it, or with the help of the namespace, we are going to pinpoint it. Okay, this student, I'm going to use it as service. So we'll see that shortly. But first we have to create a CSV file. I'm going to say data.csv. So this is going to contain data about some random data, initial data we need for testing. So the columns are going to be email, and also email is going to be a key. So we need this email to be primary key. So I'm just going to add a key before the email. Now for learners who are new to CDS, I'm going to keep the learning curve for working with CDS step by step. But still, if you want to have a good solid foundation of CDS, then you can also refer to CDS Professional Development course, where we have talked about CDS a lot. And if you watch that course and come back here, this is going to be a piece of cake for you, what I'm trying to do. So, but still I'm going to keep the learning curve very simple. So if you are new to CDS also, it will be not difficult for you to grasp what we are trying to do. Okay, so here in data.csv, I'm going to basically comma separate. The first entry is going to be the column. So this is going to be column, and that's all. Now the data, random data, I'm going to pick it up from the file because this is a lot of typing. And this is some random data, demo@demo.com. The first name is demo, last name is demo, and this is the date of sign up, which is year, month, and date format. Okay, I can also have more data. Make sure that email is unique because that is a primary key what we have defined. So okay, so that we got 4 data, 1 2 3 4 records in my CDS. Just to summarize, so what we have here is, this is basically a table, and this is the data which is inside the table. So if you have already some development experience with MySQL database, PostgreSQL database, and also in HANA database, then you can either create the data or the structure of the data by using SQL, and then you add the data in it with some kind of file. So this is similar. These are actual tables which will be created in the database when you deploy the artifacts, the CDS and the CSV artifacts, to your HANA database or to your HDI container or to even SQLite. So we will see shortly, once we run this particular project, then the SQLite database will create a student table, and it is also going to contain this data. Okay, so for us, we have a simple entity defined. You can have multiple other entities. So I can have students, courses, and then I can also have associations and relationship among different entities. So we are going to cover those in the consecutive level of level 2, level 3 difficulty. But for now, in the level 1, we have a simple entity student. Okay, so now what I'm going to do, I'm going to basically modify my service here, and I'm going to include a service which is going to give all the data of that particular student. So if we go back to our lab document here, then for that, what I need to do, I need to just create a link which basically say, using whatever the namespace I have given here, mycompany.lms, using this namespace, and here I have to tell the path where my CDS file is there. So I'm basically writing in a service, my simple service srv.cds file, so which is inside srv. So I have to come back one folder up, go to the db folder, and then I will find the student.cds file. So this is the path in the VS Code. This is one nice feature, the paths automatically show up. So I can just say it is the path, and this is the namespace for that particular file which I have used there. Okay, so inside this, I'm going to create function. So I'm going to say entity. So automatically the code comes up. If you have the plugin, CDS plugin, then automatically this template will come up. Entity, so here foo is there. So In this case, I'm going to write students as projection on, and here I'm going to say LMS dot student. So automatically I'm seeing a lot of code completion here because I have already added the path here. So it's going to pick the student structure. So the second part of the code here is basically referring to the entity we have created in the students.cds, and I'm calling the function as student. So in the browser, or maybe I can call it students srv. So just to simplify things, so here in the lab you will see here students, but you can also call it student srv, and I'm going to provide it read only. So let me just read only access, so which means that the service, student service, is going to just return the data. You cannot basically use this service and update or delete or create some data. So that is one level or one kind of restrictions which I can impose also with my service. So you can also have other annotations like create or update as well, which we'll see in the coming levels also. But for now, let's just keep it read only. Okay, I'm not going to write any JavaScript for now, which we can do later on also. So this is simple code. What we have just a entity here, and according to this entity we have this data in the data.csv, and we're basically using this entity in service, and we have created a service called student srv, which is going to expose the student entity as a projection. So basically we are going to get all the data or all the columns or entity properties exposed as a service. Okay, so let's run this code. Now before we run, I'm going to install SQLite 3. I can just use npm install SQLite 3, and it's going to take few seconds to install SQLite 3. So we are going to run the CDS project, and automatically the data and the student.cds are going to go inside the SQLite 3 database. We will have a table called students, and the data will be part of that particular table. Now it's going to take some time just to install it, and yes, we have it. And now I can go to packet.json and I will see SQLite 3 added here. Now there is a catch here which we will find out now. So if I run this, let me clear everything and let me run cds run command here in the command prompt. And there's a catch here. The catch here, I will just tell you what it is. If I go to the service now, let me just come here in the browser, and here you can see student srv is present. I can go in here, and there is no value here. You should basically see data, and I'm not seeing any kind of data. Now according to our tutorial, if you want to use SQLite 3, then I have to use cds run in memory. So let's follow that. I'm going to stop the server and use this run in memory, and now we have a connection to the database. So internally CAPM does that. When you write cds run -- in -memory, then it basically connects to your local SQLite database, and if you have any database artifacts to be written there, it does that for you, and then it loads the data. So if I come back now to my service and let me go to the students, and here again I don't see any data. Now the catch here, which I have to, let me stop the server here and I'm going to perform here. The catch here is basically that the name of the CSV file should be the absolute path of my entity. So the absolute path is my company.hr.lms and -sign and students. So in this case, what happens, the database is going to identify that, okay, this CSV file is basically the data of the student.cds. That is the only way it can actually understand that, okay, this CSV file belong to student table, which I'm going to create. So let me save this and also save this. Here I'm going to clear everything else and run cds run in memory. And the first thing which you will get is connection to data source SQLite memory, and here filling my HRLMS student from the CSV file and successfully deployed to SQLite in memory database. So these two steps were previously not done. If you scroll up, there was a successful connection, but no data was getting deployed to the database. So it only happens if you have a proper namespace attached to the data file, then only the data goes to the database. And this is internally done by the CAPM library to put the data in the database or whatever database you are using. You can either use SQLite 3 database or HANA database, or there are multiple other databases also which are compatible to your CAPM, so which we will see over time as well. But for now, let's go to my command prompt. It's already running, and I'm going to go back to my service and click here student SRV, and what we see here is the data, and this data is not coming from the CSV file but is coming from my database. So if I go to, I can see here, this is the call which got hit, and this data is basically coming from my SQLite 3 database. Welcome back. In this section, we are going to understand how can we add annotation to our UI. So why annotation? So our server here is running cds run in memory as the command what we ran in the previous section, and that run our CAPM application. In memory, we are actually consuming, if you go to localhost 4004, then we see that student SRV is giving us the data with values. Now you will find a small in Fury link here. Now if you click that in Fury link, what you will see is a blank dashboard. It's a UI5 dashboard where you have certain elements but there is no data visible, and also there are search field and there's also some boxes where you are not able to see the data. So why is that, and how can I add my data here? So for that, you need to add annotation to your CDS view, which we are going to perform within this section. So we are going to add UI annotation. So for that, I'm going to define inside my student.cds structure, which I created in the last section, annotation. So annotate, and here students with @ and inside this, I'm going to define UI annotation. The UI annotation is going to be an object. So first I'm going to define line item. So line item is going to be an array and it is going to contain object. So whatever you see here, if I go into the in Fury preview, so the individual elements here, these are the line items, and each line items column I can add one by one here. So the first, let me add label, and the label I'm going to give it is email, and the value is going to be email. So that is what I need here. E is small because then I need this student email data to be mapped here as a line item, and let me do it for all. So there are 4 records. So email, then I have the first name, then I have the last name, and then I have the date sign up. So let me add it here, date sign up, and let me make the label little user friendly. First name, and here last name, and date join. So that I have mentioned here. Now one thing you have to, or you will be doing, is this label I have hard coded it for now, but later on in the project you will be picking it from I18N file, because then you can easily convert this I18N file to different languages. So the internationalization is possible. And here it should be basically not curly bracket but normal bracket, and end with semicolon. Okay, so now the syntax is correct. If I save it and rerun the CAPM app again, let me just refresh the screen. I will be seeing my data this time if everything is correct. So you can see the data, and you can also see email, first name, last name, date join, the label we added into each line item. So this is the UI annotation which I have added, and here in the top, we have a search, and I can use this search. For example, if I do search something, then it will search all the records. Let me try to filter this demo record, or better will be filter this Ajay. So Ajay, if I type and enter, then ajay@demo.com, this is what will be filtered. And if I try to filter something else, let me try to filter this DI and DIN. So 3 records are filtered. So this filter, or more like search, is basically searching the entire data and filtering that out. And similarly here, these are individual selection field. Let me just reset the search by just entering blank text here. And now what I will do, I will basically remove this selection field which are not getting used. So how can I do that? I can go here and I can say selection field, and it's an empty array. So restart the app and let me refresh. So the app need to be started before you refresh. There is, so it seems there is some typo. There should be a S added, selection fields, and the first S should be capital. And now let me go and restart the application and also refresh here in the app. And what I see here is remaining selection field is gone now, and only search is available. And this makes the application look much neater. If I go and click on any button, I go to a header section. I can also add on to this header section. I will quickly show you how you can add something, but we will come back to this later on and work in detail as well. So let me add inside the UI annotation one more header info as well. And what this header info will contain for now, let me add a comma here. Let me just give here description for now, and the description is going to contain a value which is maybe email, this email. That's all. So for now, let's only add description. Later on we will come back and try to add more fields once we basically shift this to UI side. What I mean by that, I will explain shortly. But before that, let me run the server again and test if we are getting the header value. So I can go to the 404 in the root of the application and in Foundry, and I can just click on any link and I can see email in the header section as well. Now I can add more fields here like title or maybe one image. I can do that, but what we have done here is we have basically rendered, or we have created the UI with the structure itself. Now, if you think in a logical fashion, this part of the code from line number 11 to 40, which is the annotation, this is more like related to the UI of the application, and we have basically put it inside the database. So what we will try to do is we will try to separate it and bring it to a app. We are basically going to create a separate app, and this is going to modularize our application. So all the UI code, or the code which is responsible for controlling the UI side, should be present inside this app, and all the database structures are there in one particular segregated database folder, and only the database table structure, association between those, and actually the data or the sandbox test data is what this database folder contains. So that should be our way of structuring the application. So even if you go to our tutorial lab, then you will find that this is the steps. So creating UI with annotation, this is the part we focused on, and we have already documented it very nicely. So if you are trying to go through this exercise and do it for yourself, then you can also follow along. We first created a simple line item, then we added all the other line items and header info as well, and this is the final file, or the final CDS file, which you will have in the result. And then once you restart the server, you also see the code which we are getting now. Also, if you, instead of writing here a email, I can just here write first name as a description and save it and restart the server. Let me press Ctrl C and run again. you don't need to go from the beginning. You can just refresh here and you will also see the changes reflected if your syntax are proper. So here the name is what is getting printed. Okay, so this is the UI annotation. We can go back one level and we have added annotation, and because of that we are seeing the line item in our Foundry preview, which is by default created. Now the next challenge or the next stage is going to be adding a custom UI5 application to our CAPM. So how to do that? So let's go to the next section to perform these steps. Welcome back. In this section, we are going to create a UI5 application, which basically contains this annotation part. Now, why we will require that? For example, let me run the application again. So I'm going to use CDS run -- in memory. And basically, when I start the application, I see a UI. So let me refresh again, because the server was not started, so I am not able to see anything. Now I'm able to see it. What I basically see is a UI where I have some links, and these links are what will be similar if you are testing a API only. So to a user, to a customer, they need more user-friendly screen, not a technical screen. They don't want to know about your metadata, your service implementation. What they need to know about is how your application can be accessed and working with your application. So to make a Foundry dashboard or Foundry like UI and keep all the application in that Foundry UI as a tile, we will be creating a UI5 application. So how to do that, we will see in a moment. But before that, I would like to tell a small thing which you might encounter if you notice that in our last section. So if you go into this in Foundry, which is the Foundry preview, here I have the data. If I click on any particular value, I can basically go to the next screen. And so here you are just seeing the first name, but if you come back to the code here, we have also a label name and also title here, which contains the last name, which is not getting printed. Now, why is that happening? Now, the main reason why only the description is getting printed here is because we are in a preview mode and it is not yet a object page yet. You might see some of the older example where even the titles and other property of header info are getting printed here. But when you come out of the preview mode, this will be possible. In the annotations, if I add, we have at present selection field, line item, header info. If I add facets, so I will be able to see the values here as well. Now we will work on those annotations or UI annotations as well in the coming section. But in the level 1 of CAPM, we want to give you an end-to-end perspective of how to work with application development with CAPM. So in details of annotation, or may it be service, or may it be JavaScript part of the service implementation, we will go in the consecutive levels. So for now, our focus is to complete the entire application to give you a end-to-end perspective, and perspective which we will then increase the depth of. So that's the reason why we are basically skipping a lot of parts which we will cover in the coming sections. Okay, now in this section, our focus is how can we create this UI5 application, which we already discussed why we need it. So what I'm going to do for that. So let me come back, and here I'm going to create a app folder inside the demo, which is going to contain all the application or UI5 application related artifacts. Now, if you come back here to our lab document, then this is the folder structure which you have to create. Now, inside the app, we will have index.cds, index.html, and there is a folder which contain web app, and this web app will contain a component.js and manifest.json and Foundry service.cds. Now, there are a couple of files. Mostly this component.js and manifest.json, and also this index.html. These three files are something which will be generated if you are working with a full stack cloud web ID. Then these artifacts will be what will be generated if you say new, create a new UI5 application using the Foundry sandbox. Then the index.html will be basically the standard Foundry code or standard UI5 code where you can put some tile, and the manifest.json will be a structure which will just contain what are the data models you want to access within the application, what are the routes which are defined in the application, and the component.js is just going to link manifest.json to the application. So some of the files will be generated if you are working with full stack web ID automatically as a template. So we have those code written here because these are standard UI5 Foundry code which will be generated as a template. So we're not going to code them manually. So these are just standard UI5 sandbox code. Put a tile, and we are just going to copy it from here. So let's start creating the structure. So I'm going to create a new file called index.cds and then index.html. New. Now this index.cds, what it is going to contain. Now index.cds is going to tell your application all the CDS or all the UI annotation where they are presented. For example, let me create this student folder, student details, new folder, student details. This is going to hold our web app, which is basically the UI5 app. So new folder, web app, and here inside that component.js, new file. So mostly we are dealing with now a UI5 application creation. So I'm just quickly navigating through those files. New file, Foundry service.cds. Now here the Foundry service.cds is going to contain the annotation which we created in our DB, because annotation are basically the part which is responsible for rendering the UI. So we want to shift it from our database layer to the UI layer. So what I'm going to do, I'm going to basically change this or shift this, the entire annotation thing, from the student.cds to my Foundry service.cds. So we have here that. Now, one important thing here we need to consider is to whom or to which part these annotation which we have basically shifted to Foundry service.cds inside web app should be applied. So to whom it should be applied? We are basically going to select our service, and here if you go to my simple service, I'm going to take this my SRV demo, and from here I'm going to pick this student SRV. So student SRV is the service in which we want this annotation to be added, because in rendering our UI, this service is what we are going to use. So instead of putting it on the data or in the database part or the structure of the database part, we are basically now trying to get the service, because if you see the metadata of a service which is annotated, you will find all the annotation information there. We have also covered this in details in the UI5 2019 course and also in the CDS course, that how you can see a service which is annotated, and basically we are going to grab this service and try to add the annotation to that. So how will we do that? So basically we will say using, I'm going to keep the name same, you can have a different name. So the syntax will be using this student SRV, not the student SRV. Here the service is my SRV demo. So I'm going to take that my SRV demo from, and the path is, I'm going to go up one level and again one level, and then enter into service and this, and my SRV demo dot student SRV. So I'm getting that particular service which I have implemented, which I have added inside the service. I can get the student service also reference in my ID. So basically I'm going to add this UI annotation to this service. So when we are using this service, the UI information of how to render the UI is also part of the service itself. You can also have different variable if you're using my service and add a keyword as some new name. Then you can also use some new name here. So I can just delete this and say some new name dot, and also I can now refer to my SRV demo. Sometimes it is essential because you have a lot of variables, and this some new name will be much more user friendly and readable. This is a good standard to have a new name defined to the service. Here you can have any name. I'm just writing some new name just to point out that this name can be anything which you want, but that should be a valid identifier. So for now I can just get rid of that and add here maybe service student, and that maybe I can use just to have a meaningful name. Okay, so here the service is now added with the annotation. So if I use the service, I can render the UI. Now coming to my index.cds. Now, as I have already told, it basically will contain all the CDS file inside the project which you want to basically use. So here I only have one CDS file. So the index.cds will contain a linkage. So we are basically modularizing the code. So this index.cds, instead of I adding a lot of annotation in the index.cds, I can have multiple different CDS file, and this multiple different CDS file might be for different pages. So for page 1 there is one CDS file, for navigating to page 2 I have a different CDS file, and here all those reference we will be adding. Now it is not much clear at this point of time, but once we increase the complexity of application and you will see those, you will get more clear idea. But for now, in the index.cds, we are going to just link the reference to Foundry service.cds where we have just added the annotation. So I'm going to say dot student detail, and here automatically the file is getting picked, and save it. In the index.html, there is standard template code which will be auto-generated if you are using full stack web ID. We'll also see how to do this in full stack web ID in coming sections. And I'm just for now going to copy this code. What this code does, we are basically creating a tile, and this tile is going to contain the title manage student. This is for student management, and once you click on that, it is going to take you to the web application where our UI5 application is present. So this is the auto-generated code for the Foundry dashboard where the apps can come up, where apps can be placed as a tile. And below here we have the standard codes of including library of UI5 and attaching a init function and placing it to the content. So that's part of standard UI5 template code. Okay, now coming back to we have already worked with index.cds. We also know what is the code stands for. The component.js, the code is also standard, which is auto-generated if you work with full stack web ID. And it basically includes manifest.json file and links it to the application as a component. So this is going to basically use manifest.json file. Some part of the manifest.json file is going to be auto-generated. So let me use a sample manifest.json file, because there are a lot of part of this manifest.json file which you have to work with. But version, SAP app ID, application title description, and also dependencies, these are something which will be auto-generated. And let me start from here. So let me basically remove the comments here. Now in my UI5 application, if I want some model to be added, model is basically containing the data, and this model is basically linking some service also. So I have to define that service initially as a data source, and then inside the model here I will be adding that data source. So if you add here that model, then this will be linked to the application, and the application here, there is no name, so this is the global model. If I give it some name, some model name, then this will be a named model of name, some model name. So these are pretty much standard UI5 code, and I hope that you are familiar with UI5 because that is one of the prerequisite for working with CAPM. If you are not familiar with UI5, then you can also see our UI5 2019 course where we have worked with manifest.json in details, even went inside the library and debug a lot of standard code also for our learning. Okay, so data source name. So what should be the data source name? So the data source name, what I will give is the name of my service. So here my SRV demo is something which I will keep, my SRV demo. The URL to reach that. So the URL to reach that is slash my SRV demo and end with a slash. So even in here, you will see some of the commented line, which will tell you how to basically fill this part. There are certain parts which I have removed from my code and I've added commented line because the name you give, based on that, the variable or the value here will be different. Okay, so here my SRV demo, which is basically the service we have inside here, my SRV demo. Okay, coming back to the manifest.json. So you can also test this. If I come back and run my application with cds run -- in memory, then I can basically come back here, localhost 404. Let me see if the app runs. Yeah, the app is running. It is basically going to shell home where it will find some error because we have not finished our coding yet. I'm going to just test with the path which we have mentioned, my SRV demo. If I go to my SRV demo, does it exist? And yes, it exists. And after that, student SRV function should be utilized to access that. And if you want to see metadata here, then you can also use this $metadata hash student SRV, and it will show the metadata with annotations. So here the annotations are present. So if I'm using this service, automatically my UI will be decided what should be basically rendered. So the UI line item, so UI annotation basically takes care of that. Okay, so this is the path just to get confirmation, slash my SRV demo slash. So that is what I'm using here. The type is OData, setting OData version 4.0. That is a standard code which gets generated if you create the UI5 app in Full Stack Web IDE. Here in the model, I will select or give the name here, my SRV demo. This particular object or this particular link to the service, use it and create it as a data model in my app. I have not given any name here. That means it is going to be a global model. Okay, and there are some routing which will be auto generated. So here we have one routes. So the pattern is colon question marks query colon. There is no query we have provided here. That is just a blank pattern. And this is going to point to the student target. And in here, in the targets, we have a student target. Type is component, and the type of the component we have is a list report. So this is for templating. The data is going to be generated or added as a list report. And in the option, there's a setting where we have to specify what from the service we have to select as an entity set. So in this case of our service, my SRV demo, which is basically here what we have mentioned as a data source, we will see that going into my SRV demo, we have one service which is basically can be utilized. If you have multiple other service defined, here in my simple srv.cds, here we have student SRV only one. But if you have multiple other entities defined, then you can basically use any one of the entities. But for now, only student SRV is there. If I go to student SRV, I will get the data, and these data are coming from my database, and here the database is SQLite. I can also see the metadata which we have just seen as well, and here annotations are present. So this student SRV is what I'm going to add in my manifest.json as entity set, and that's all. So just to recap what we have done here, we have basically manifest.json file which contains information about UI5 application. It contains information about the data source which is linking the service, then the model which is linking the data source, and this is the global model because we don't have any name here. And then we have routes, and the routes is basically targeting to a list report template using student SRV as entity set. In the component.js, we have standard code of including manifest.json. This code will be also auto-generated if you're working with full stack web ID. Then we have Foundry service.cds where we have the annotation. This annotation are getting added to your service mysrv demo.student srv. So student srv is basically getting annotated from this place. And the index.cds is a place where you can have linkage to multiple files which contains annotation. For now we have only one, so there is only one entry we have. And index.html file is basically the HTML5 code for creating a Foundry dashboard or Foundry launchpad where our tile is present. So we have basically added one tile here. The rest of the code is same what we have used in the last section. We have just moved the annotation from our student.cds structure to our Foundry service.cds. Okay, let me stop the server and start again. And I'm going to start it from the root of the URL, which is the localhost 4004. I'm going to see a Foundry launchpad. At this point, we have only one tile, and the code of the tile is your application part here, which is basically a managed student as per the title, managed student, and here student management is the description. If I go inside this, I will see if all the codes are proper, a list, and yes, we have a list, and we have a search, and based on the annotation we have one selection box as well. Let me check if the search works, and yes, the search works. And also let me check if the selection work for the email, and yes, this also works. So this selection is for the email. The text here is not coming, the title text for the selection box. To make that appear here, what you can do is you can basically change. I can go to the structure here. Where is my structure? Inside the DB student.cds, I can basically add that title, and I can give the title as email. I can give similar titles to other fields also if I want, first name and so on. I can also give. Okay, let me restart the server, and once I restart, let me refresh. I should get the email here at the selection part of the email, and yes, I got it, and this is because of the newly added title. Okay, if I click on this particular items, I'm not going to go to the next screen because we have not yet added in my manifest.json the navigation part of the routes. If I add it, then it will also go to the next section, which we will see in the consecutive part of this course as well. Now, as per the level 1, what we will do, we have created a good looking or like manageable UI5 application, which is part of the Foundry launchpad. Now the next target will be to deploy this to SAP Cloud Foundry, and instead of using SQLite database, how about using HANA database? Or if you are using a free trial, how about using a HDI container? So that will be part of our next steps. So let's catch up in the next section to deploy this code to SAP Cloud Foundry and replace our SQLite database to HDI container, because we are going to work with a free trial account on SAP Cloud Foundry, and using the HDI container we get this data. So let's catch up in the next section to perform that. Hello and welcome back. In this section, we are going to see how can we deploy our application, which we created in our last section, to SAP Cloud Foundry. Also, we are working with a local SQLite 3 database. We will also explore alternative options. How can we use HANA database? If you go in SAP Cloud Platform and work with Cloud Foundry, then you will find that in free trial, HDI container is what is given to you. So initially I only have dev, and if you see the breadcrumb sequence here, the first is the Cloud Foundry trial, then the trial is the sub account which I have here. I went inside the sub account and I found all the spaces. Here dev is the default space which I get if I go with free trial. If I go inside the dev now, I will be able to see what are the services which are present. We have a service marketplace. You can also see the current service instance which are active by going into this service instance tab. So let me come here to service marketplace, and there are a lot of new services which are getting added rapidly. So you might find more services here when you will be working or you are exploring this. So if I go with HANA, then I have this SAP HANA schema and HDI container. Here in a gray text, you might see HANA trial. This is what we are talking about. In the free trial of Cloud Foundry, you will get HDI container. You can create HDI container. You can use HDI container. In the previous section, we have already done the microservice app with the HDI container. And in this section, we will be also using the same HDI container. We are going to create a new HDI container, and this time we are going to use the command prompt. Previous time I used the UI. Now we will try it a little differently. So the command prompt side of the work is important, because if you want to automate those activity, then you just have to automate the command, and you can open a shell and run those, and you can automate those in a script as well. Okay, now one essential thing, or one thing which was a limitation in the last section, which was when I try to create artifacts like tables, then in HDI container, I can do it only with the SQL. I was able to do the JPA implementation. If you remember, if you have gone through the last microservice of the Cloud Foundry, the initial JPA, the tables and the table structure are automatically created in the PostgreSQL database. But we only had our HDI container. Then we were not able to create those artifacts from our Java Spring Boot automatically. Now, HDI container is not a HANA database. If you have a HANA database, then you will be able to do that, because HDI container is just a layer over your HANA database, and you have to pass the SQL command, and those are run on the HANA database. Regarding the difference of HDI container and HANA database, we have seen in details in the last section, so you can refer to those parts. But the point here is that with the help of our CAPM programming model, we will be able to create artifacts in our HDI container in runtime. That means when my program runs or when my program get deployed, at that particular time, I can create tables, structures in my HDI container, and all of those are internally managed by the library. So you as a developer, you are only focusing on the structure which you have, which is the CDS structure. In my DB folder, I have the CDS structure of students, and I have the CSV data. You don't have to go inside how the SQL commands are deployed. You will just build and deploy, and at the time of deployment, you will see all those table structure getting created. So this is one of the very exciting part. So if you are creating some POC in SAP Cloud Foundry, then CAPM is providing you very nice out of the box feature to deploy in the HDI container, which you will have access here. So let's see how we go forward within this section to first build our application and then deploy to SAP Cloud Foundry. So let's start the steps. Okay, so coming back to our project here, in the package.json, we have @SAP/CDS. It was added to the package.json initially when we created this project with the help of CDS INIT. Then Express was also added, and manually we added after that SQLite 3. Now let me show you one more way to run our application. Let me come back to this demo 1 and clean. So we are in the demo 1 folder. Now what we are doing to run the project in SQLite, CDS run -- in memory. So that is what we are trying to do. So if we go here and we just go to the port 4004, and you have to also check if the server is started here in the console. There might be some error and the server stops, and then you are just investigating why my app is not working. So just have a look in the console as well. Okay, so automatically it goes to the shell home because we have a UI5 app implemented in the last section inside the app folder. And if I go inside this tile is created because of the HTML5 code inside here, the app folder, and it is basically creating a tile as a SAP U shell. So that is basically a U shell, which was in this case, it's a U shell which is holding the tile. If I go inside, we have the list, a search, and this is the for email, and that's all. So this is what we get from the last section. Now what we are going to do, the first step which I will show you, instead of running CDS run in memory, I can deploy directly all the data here to my SQLite database. So if I clear everything and say ls-la, so L will list all the files inside this folder, and A will basically show all the hidden files also. So normally if you have any files with a full stop or dot before the name, then that is the hidden folder or hidden file, so which you will not see if you just do ls-l. So what we have here is dstore.cds-src.json, some git ignore, and VS Codes extensions, and the folder which we created, app.dv, node modules, packet.log.json and packet.json, and SRV folder. Now what we are going to do, we are going to just write CDS deploy. So by writing CDS deploy, we will see some of the commands of using CDS deploy. So the command CDS deploy is actually incomplete, but basically works like a help scenario. So where I can know that, okay, how to use this CDS deploy command. So one command is CDS deploy to SQL, to SQLite, and then you can use other database also. So if I come back in my VS Code, open the packet.json, I have no database configuration added here. As soon as I write CDS deploy, and I will say -- to SQLite, and as soon as I do that, you will see the data will be written to SQLite database. And in the packet.json, that is the first thing. In the packet.json, I have now this entry, CDS requires DB, kind is SQLite, and model is db/srv/app/. So these are the folder to refer, and then this database is what we are using. Now coming back here, ls-la, you will find one more file added. So SQLite.db. So SQLite.db was something which was not added or which was not present previously, but as soon as we deploy to SQLite, locally a database is created and all the tables has been written what we have inside the DB folder. Basically it will search throughout the project for all the structure and data and add it to our SQLite.db file here. If you try to open it, it will say that the format is a little different, and you can just open it anyway. And you will see some of the random text here which are unreadable from the VS Code. With plugin you can read it. We will also see how to do that, but you can just see some of the text content. These are the table structure, and if you scroll to the right, then you can also see some data somewhere here in the data. So not a very meaningful information, but you can get an idea that, okay, it contains information about tables and data. Now, if you want to see the content of this SQLite.db properly, then you can also install plugins which are available, install plugins extensions. So I can just go to this extension, this square box in the middle, in the left hand side, to search available extension. So SQLite, I can just search SQLite. The first one, SQLite from Alex CVZZ. So this is from unofficial source, but you can install it and test how the SQLite database is, what are the table structure. If you are interested, this is basically an additional step. So if you are really interested, then you can proceed with this steps. You can install it. I have already installed this plugin, so I will not install it again. Now coming back to the file here, let me close this. I can press Control P in Windows and Command P in Mac, and I can just write greater than symbol, and here open database I will just write, and it will automatically go through the entire project and find all the DB files. And I have this SQLite.db, so I will just click here, and if I open it, I will see the table what we have, my company _HR.lms _student. If you compare this name with the name which we have given in the CSV file, we used a dot. Now in the SQLite database, it is actually underscore. So this conversion automatically gets handled inside the CAPM library. So it was the CAPM library which created this table, and it automatically knows that what are the format which a database need to have. So SQLite will not require dot, it require a single string name as a table. So it basically added underscore instead of dot. So similarly, if you try to write this to HANA database also, it will take care internally those requirement which are set by the database. So I can right click here in the table and I can do show table, and it will basically show me the data in a nice tabular form. So this is the query select star from the table name which was executed in the table, and I got the data in a nice tabular format. So this is something which is not must have, but good to know if you are working with SQLite database. Okay, coming back to our project, let me minimize this. Now what we have here is this part of the code which was automatically added to my packet.json when I deployed my artifact to my SQLite database, and a new .db file is also created locally. Now if I want to run this project, I can now just skip the in-memory part and use cds run, and it will automatically take the SQLite.db file because that is now part of my package.json file. So if I go to my browser here, refresh, then I will see the same output because now the SQLite.db file is getting used to get those data. So that is what we have done. We have basically deployed to a local .db SQLite file, and now we are basically using that to run our project. Okay, so this is about the local database of SQLite, local testing, you can use it. Now how about using a HANA database or an HDI container? Let's catch up in the next section where we are going to first create a HANA database or HDI container in our case because we have a free trial account. How to do that? And this time I'm going to use command prompt to do that in our SAP Cloud Foundry. And once the HDI container is created, then we have to build our project and then push our application to deploy. So let's catch up in the next section to work on that. Now coming back to our lab, if we see the sequence here, first we are basically generating the build. After that, we are going for creation of the service. Let me create the service because it's going to take few seconds, and within that duration we can also work on the build part of our code. So multitasking and using the latency to fill the gap. So let's see the SAP Cloud Foundry, and if I go into service instance to check what are the services which are running already in my account. So I see that there is no service. You will find this inside your sub account, which is by default trial, and by default dev is the space which is created, and here I don't have any service running. So I can manually create a new service by going into service marketplace and starting an instance. So I can go and just search HANA here, and I can select this HANA trial, and I can basically come here to the instance and start a new instance. So new instance here, the option is given, but this time I'm going to do it from the command prompt. So if I go and let me just take this command cf create service, and then if you just enter here cf create service, then it will also give you the naming convention of it. So here create service, it should have first the service, then the plan which you are going for, then the service instance name. The service instance name is something which you decide based on your project, and you can also have broker or parameter as JSON or tags if you want to add to this particular service. So these are optional. So for now, I'm just going to take the cf create this and cf create. The service name is HANA, and I can also check it by going here. So if I go to the overview part here, then this is the plan here. The service name is something which we saw in the service marketplace. So if I go back to the dev here, then in the service marketplace, just search HANA here in the gray color. This is the service HANA trial. So HANA trial, TRIAL trial, and the service name, if I go inside here, then the service plan name, the second argument is basically plan, which is HDI shared, and then I can give my database or HDI container name which I want. So some HDI. So that's all. You can also add tags with -t or brokers with -b. So that are optional. So we'll not do that. Let's execute this command, and the creation of service takes some time. So if I run this command cs service some HDI, then you will see that it will basically show me what is the status of the operation. And if I come back to my dashboard UI here in the instance, you will see creation process, which will be already started. So that is what we see here. We have the creation going on in my UI. Okay, so it got created, and what the next thing which we want to do. So now you can come back just to show you the status here. So it will be created. If you again go for CF service some HDI, then you will see here in the command prompt, the status is create succeeded. That is the status. Now I'm also showing the command prompt because sometime when you are automating task using script, then command prompt operation are what you write. Okay, now the next activity what we have in the lab, or the step which we will perform, we are going to build our project. So what is the meaning of building the project? So when we build the project, in this case, we are basically talking about building artifact. So we have the database folder. Inside that there is CSV data and the student.cds data. So this student.cds is defining the structure what we are using in our project. When we run this artifacts in our HANA database, it will not consider CDS or the CSV data as the required format which a HANA database need to create tables and to add data on the table. So when we build, then we are basically converting the artifact to a language or a format which can be understood by where we are actually going to build it. So you think it as a translation process. If you don't understand a language, then build is basically converting that non-understandable language into a language which you understand, maybe English or something else. So that is the that is the operation which we are going to do it now. Now in the build process, we have to basically define all that for which we are actually building this project, for what operation specifically. So I'm going to put all my build inside a folder called gen. So that is not present now in my project, but will be created once the build gets succeeded. So here, if I copy the code, there are a lot of artifacts which you can build. You can build the database, you can build the service, you can build the app. So if you see here, this is the parameters. Source is the folder name, then for which type of project you are building the project, and options, what are the linkage need to be done in the build. So in our case, we only need to build database artifact because that is what we are going to put in the HDI container. So here, if you scroll down, I just have also a single line just for the database artifact. Let me just take that, and I'm going to come back here and add it here. Okay, so what I'm saying by this, take the DB folder, and keeping in mind that I want to deploy this content of the DB folder to a HANA database, build it for me, and also take care that the models which this database uses are in the DB folder and are also present in service folder. So that is what we mean when we add a task. So the task here is an array of object, and each object is defining a particular build. So you can have multiple build together executed at once, and they all will be put in a gen folder. So in this case, we are building it for HANA database, and let's save it. And you will see that this is the place where you actually realize that there is a lot of development which is already done inside the CAPM, which has the capacity to take all these files and convert it into HANA compatible artifacts. So let's go and do that. So I'm just going to run the command cds build, and I just want to run all the tasks which are inside here. At this moment, I only have one task to take the DB folder content and convert it for the HANA database, considering model inside the DB and SRB folder. So I will say build all, and it will also show you what is the script which ran, and what are the files which are created and from where those files was created, or what file was referred and what file was basically created. Okay, so that is in a folder called gen. We have this gen folder now created, and we'll find a DB folder inside that. And here you will see we have a packet.json. And if you see the start script here, this is interesting. It is basically running a task node modules @SAP HDI deploy and deploy.js. So this is the location of the JavaScript file which will be actually executed. So if I try to search this deploy.js file inside my DB folder, I will not find any deploy.js file because at present we have not used the command npm install. And if you remember, when we write the npm install, then only node modules are created and added to the project. So the DB folder itself is now a node project, and there we have a packet.json, and also you will see there is a manifest.yaml file created, which we'll see shortly. But let's see the other file which are generated. So we have a folder called source, and inside source we have gen folder, csv, and there's a .hdi config, .hdi namespace, and then there are certain files which are hdb cds and hdb cds again. So this more and less looks like some kind of SQL command. And you can see here generated by CDS compiler version 1.192. So what basically happened is when we build the database artifacts, it basically took the student CDS and it passed it through the compiler of CAPM and converted it into some HDB CDS files, which now can be deployed to a HDI container or a HANA database, and the HANA database is going to basically treat it as a command to create table, and also we have inside CSV data. So you can see here the formatting is done here. So this is basically conversion to a format or to artifacts which can be understood by the HANA database. In this case, it can be HANA database, or it can be maybe SQLite database, or can be any other database. So you just are translating your artifacts into the artifacts which the target can understand. So that is what build process is. So in the level 1, we are just building the database artifacts. In the consecutive level, we are going to build the services also and app also. So we'll show you that part as well. But the task is basically written inside .cds rc.json file. And when you run cds build all, it basically runs all the tasks and converts your folders or the task into a translatable formats to your target. So that was the build process. Now what we have with us is this gen file, and inside the gen file we have the DB artifacts. Now what we have to do now, if you think logically, what I have with me, we have the artifact inside DB. So this artifacts are going to connect to my HDI container and create tables, and whatever tables is created, that table is going to be utilized by my app. So this is my app which I'm running in here with CDS run. So the same Node.js app, I want it to run in my Cloud Foundry. Welcome back. In this section, we are going to deploy our project. Now, the first step is to imagine what actually we want it to happen. So if you see our folder here, we want this generated DB artifact to go in the cloud and connect to my HDI container, which I created in the last section as a service, and create the tables, create the data within the tables. And once that is done, I want my Node.js application, which is what we are running with CDS run inside my demo1 folder. It should get deployed into Cloud Foundry, and it should basically utilize the HDI container, what we have created and where we have added the data. So that is the objective, or that is what we want it to happen. So let's start the process. So how we are going to do that? We are going to create a new file called manifest.yaml. You can either have YML as extension or YAML. They are both same. So manifest.yaml. Now, when I create this manifest.yaml file, then I have to add in a sequence what are the projects which need to go. So I can also take from the manifest.yml file, which was automatically created inside the build. I can just take this code and use it here, because the first app which we are going to push is going to be the DB folder. So this is the app. This is basically a Node app with a packet.json, and this should basically create the HDI and create the tables. And I have already taken the manifest.yaml code here. Let me name the app as HDI config DB or HDI conf, just that. And path is dot, which means the current folder, but when we move it to the manifest.yaml file inside the main or the root of the project, then I can just give it the path as /gen, and then inside the db /db. So that is the path, because inside the db all the artifacts I want it to get deployed. And no routes true, health check type process. this is very important argument, health check process, because what will happen is it is going to run a script called deploy.js, and once the script completes, it is going to create the tables, it's going to create the data within the table, and all that process will take place. And after that, this app should not start, or that is the end of the work which we required this app to do. So if we don't write health check type process, then it will look for a script to start the server, and it will continuously look for it. And then this step of deploying HTI config, or this generated folder what we have, will go into a continuous pending state. So if you just remove this, then you will find you can do the test from your own side. If you remove this part of the code, then the app will go in the cloud and it will continuously look for a script to start the server, and it will not find that, and it will go in a continuous loop situation. Now here the memory is 128 M, which is megabyte. The service is what we have created now, so we will give that. So let me come to my console. I can just write CF services, so it will list all the services what we have. And this is the name. Where is the name? This some HTI. Some HTI is the name of the service, which is basically the HTI container. Then I'm going to bind it to my application, and the second application which I want to also send to Cloud Foundry, let me have one more tab here. The formatting need to be added very carefully, and this should basically go one step right, and now it is proper. So this is going to be the node app. I can just say CAPM L1 level 1, and the path is the current folder, so I can just say dot, and which will basically include all the content here. And then no route is true, and health check, I don't need health check process. No route also I don't need. Basically I'm deploying this app, so if I don't pass any route, then automatically it's going to give a URL to it. Or you can just say random route as true. So if the CAPM L1 is already taken, then it will try to give it some random URL. Memory is 128 M, and also bind it to some HTI, because we need this service to act as the data source for our application, and that marks all the configuration what we need from manifest.yaml file. Now there's one very important thing which I have to tell you, because we are dealing with manifest YAML a lot. There are other files like somewhere down the line here. So mta.yaml. So many times you will see the mta.yaml file also getting used in deploying the application, and you will wonder why we are using manifest.yaml file. Now the main difference between manifest.yaml file and mta.yaml file is that the mta.yaml file is a superset, or is a extra feature of manifest.yaml file. So if you take this manifest.yaml file and add the extra features to it, then the mta.yaml file is what you will get. So there are a couple of things which you can do with the mta.yaml file, which makes it better way to deploy application in Cloud Foundry. So one of those is that with the mta.yaml file, within this file you can create resource bundles, and you can add in your application the resource bundle as dependency. The other thing you can do is that you can specify the name of the entire project and version and manage the version. And when you deploy a mta.yaml file, then it basically creates a zip for the entire project and deploys that zip. So that are the main difference, or the major difference. In the learning process, I find that manifest.yaml file is much better, because when you're working with mta.yaml file, the syntax will be almost same and you can easily recognize those. But in the manifest.yaml file, if you are learning something new, then it brings some kind of simplicity. So I'm selecting manifest.yaml file. over time, we are going to also see some of the projects where we use mta.yaml file to deploy to cloud. But for now, I'm using manifest.yaml file. In future, when we increase the levels, then we are going to also see mta.yaml files. Okay, so this is the app what we want in the Cloud Foundry to run. There are a couple of changes which need to be done in my main app inside the demo1 folder. If I go inside here, now for some reason these two folders are added twice, the demo1 and the demo1. So this is the same folder. So basically somehow got added twice in my VS Code. Okay, so that is not related to development, but something which happened. Now coming back to the changes, what we have to do in this demo1 folder, the changes are I have to go inside the package.json and change here the kind to HANA. So that is one change, or the first thing, because in SAP Cloud Foundry, we want HANA or HDI container to bind to my application. I don't need SRV or app, but for now, let it be there. It is not going to give any kind of error. But one thing which I have to do, which will basically give me error, is to uninstall this SQLite 3, because for some reason I'm getting an error number 4 if I don't remove this SQLite 3. I can just remove it from here, or I can just write npm uninstall SQLite 3. So this will basically uninstall this particular dependency, remove it from package.json, and also go inside the node modules. I'll delete that. But when we deploy to Cloud Foundry, the node modules actually are not deployed. So I can just remove this particular file from here. So when basically it runs in the Cloud Foundry in a node environment, then it will not find SQLite 3 and it will not basically give me that error. So that is what it is. Or you can just uninstall it from the project itself. It's your wish. We can have both approach. Now, one more new dependency which I need to add is npm install HDB. So the HDB is something which we already saw in the microservice week where we created the microservice app. Now HDB is going to be required to establish a connection from my Node.js app to my HDI container or to my HANA database. So that module is required. So when I do npm install HDB, then I will find in my package.json that dependency gets added. And also inside the node modules that will be added, but node modules are not sent to the Cloud Foundry. So I just need to be worried about my package.json. So when I say that node modules are not sent to my Cloud Foundry, that is when I'm using manifest.yaml file. So it's only going to send the source codes of my project. Okay, let me save everything. Let me just double check. I have the HDB. I have my HANA kind as a database. That is done. I also have a gen folder in which all the DB artifacts are there. And I can also remove this SQLite because if it goes, it's going to just take unnecessary time. Now let me come back to my web ID, full stack web ID, and I'm going to add the newly created HDI container. Just the same steps. I have the data source plugin, and here only one HDI container I have, some HDI, and press OK. So it's not going to have any kind of data or any kind of tables now because this is freshly created. If I go to tables, it's empty. Now let me come to the command prompt here and use cf push command to push both the application to Cloud Foundry. So it will pick it from manifest.yaml file and start the deployment process. So first the HDI config is the application name, and it will basically send the generated or the build database files. And you can see the progress here. It's going to take few seconds, and once the completion of the deployment is done, I'm going to resume the video. So the end result is success in both the app. So the first app, if I scroll up, got deployed, and this is the second app, which is the main CAPM app what we have. So in the first app, which is basically the deployment of database artifacts. If you see the logs for this particular app, HDI config, if I go and say CF logs HDI config and -- recent tag you need to add to see old logs, then we will also see the logs of deployment of our database artifacts. So there are some library which got downloaded, and from here you can see that connection to the container and preparing the transactions, and there were a lot of database artifact which was merged with the HDI container and deployed as well. And then you can see that inserted 4 records of data source file, my company.hr.lms students. Okay, so what it means is that we can go to the full stack web ID and we can refresh the table here. And let me just refresh, and I'm going to see the table. And if I go to open data, then I will also see data for records in that particular table. So within a moment we will see that, and yes, we have the 4 records. Okay, so that is what the build database file did for us. Now coming back to the Node.js app. So if I scroll up, this is the Node.js app, and I can basically take this URL and run that. And if everything is correct, then I will see the same app which was working in my local machine working in the cloud. So here we have the shell and a tile, and if I click here, I should see a list page. And yes, I see a list page. And let me also check the search here, and yes, it works. So this was the process of deploying our application to Cloud Foundry. Let me summarize what we have done so far. So we basically first created a container in our SAP Cloud Foundry, and this time we have used command prompt to do that. There is one more interesting command by which you can not only create your container in your SAP Cloud Foundry, but also can add the required dependency in the package.json. So this is the required dependency. So I will show you later, but let's first summarize. So first we created this HDI container. Then we get this dependency here in the package.json when we actually write the command cds deploy to SQLite. Initially it was SQLite, but when we are deploying it to the Cloud Foundry, we are doing it for HANA database. Then we just change it to HANA. Now the database artifacts we converted into a format which the HDI container or HANA database can understand, which is inside the gen folder inside DB. And here this was all created by the build process. For the build process, we went into .cdsrc.json file and we added the task. So only one task we have here, which is to get the DB folder and convert it for HANA database. And that basically created all the artifact inside a folder called gen, which we mention here in the target. So internally in the CAPM, it is what gets done. And here all the artifacts got created. After that, we created the manifest.yaml file where we are first deploying the database artifact, which is connecting to the HDI container and writing all the files and data to the database or the HDI container in this case. And then we are basically deploying our Node.js app, which is the CAPM app we have. And now we have the database tables and data in it, the HDI container, and the app using that from our UI5 app using the data from the HDI container, all running in the SAP Cloud Platform. In this case, the SAP Cloud Foundry. Okay, so this was the entire process. One small detail which is good to know kind of information, which is if I come back here and I basically delete the package.json content, let me delete this part. This is required in the process of running the application. If I just delete this, then we basically use the command cds deploy. We basically started with this, and if I just run this, then it will show me options. Cds deploy, this will show me options unless I have already deployed to some database like SQLite. So I can also this time do cds deploy to HANA. Now as soon as I run this command, what it will do, it will basically try to see if you are logged in from the CLI, from the command prompt to your Cloud Foundry. So if you are already logged in, then it will automatically create a HDI container for you. And once the creation process is done, it will also add the script in the package.json for you. So let's just run this, and you can see that starting deploy to SAP HANA. So it basically said, okay, there is no HANA. So it said, okay, let me create the HANA trial. And basically it is a fallback mechanism. If you are not having a paid account, then is the HANA trial what you can use. So first it created, or it tried to create HANA database. If you don't have that, then HANA trial it tried to create. And now the process is ongoing. If I come back here and if I refresh, then you will see that there is this demo 1 DB HDI container is what will be in the process of creation. So here you can see that it's still in the creation phase, the demo DB HDI container. Now I'm going to pause this video because this is going to take few seconds before the task gets completed. And once the task gets completed, I'm going to tell you line by line what happened. So the task got completed and a lot of thing was done. The first thing it tried to do is try to create a HANA database. We are in a free trial, so it fall back to HANA trial creation because we are not allowed to create HANA database with a free trial. Then it started the creation of the HDI container process. The name it gave to this HDI container is demo 1 DB HDI container. And once the container creation was done, it took some time to create the container. Once it was created, then it basically tried to connect with the container, and it also created, or it also installed a dependency called SAP HDI deploy, which is required to deploy the artifacts. And it basically wrote files to this HDI container. So first the locking of the container, then synchronization of the files, 6 modified or added files, and then they were deployed. And we have a lot of logs of the deploying and merging here. And finally, it basically released the lock. And now if I come back to the project, I see in the package.json where I have removed this part. Previously, it was written here SQLite. Now it is written HANA. And also there is a production string written here in the key of this particular configuration. And if I come back to my web ID and let me add that HDI container, let me look for it, which was by default created, demo 1 DB HDI container. Let me add it, and I will close everything else of the previous HDI container, and it got added. And if I try to see the tables of the new HDI container, and I also have the same tables, and if I see the data here, then I should have the same data as well. Okay, so we have the same data. Now in the previous step, what we did, we created the container, we put the data there at the time of deployment. Now with just a single line of command, which is CDS deploy, let me come back all the way to the top. Here, CDS deploy to HANA, with just this command, I'm basically creating multiple things at once. I'm basically creating the HDI container in the Cloud Foundry. First, basically, it will try to create the HANA database. If not, then HDI container, then it basically writes the files and adds the data, and also adds in your package.json the configuration required for your CAPM app to connect to this database, which is basically either HANA database or HDI container. Okay, so this was the end of the level 1 of CAPM. I hope that you had a wonderful time learning. If you have any questions related to this level, then you can ask that in the discussion forum next to this particular section. So let's catch up in the next level to understand more about CAPM.